All right, people, there's not a crazy amount going on here with inverses. I'll try to make this quick. An inverse is exactly what it sounds like. We're switching things around. We're changing the order. In our case, it's going to be switching the x and the y. So if they give you a bunch of points and they ask for the inverse, well, we would do exactly what it seems like. We would switch the x and the y. And those points would all be the inverse of those original points that they gave us. Now, here's more of what the application is. If we need to find the inverse of a function, let's say it's a line. You're going to have more than just lines, but lines would be the main one. If we're going to find the inverse, we know that f of x just means y. So first, I'm just going to write this as y equals. Next, like I said, finding the inverse is just switching the x and the y. We call it the old switcheroo. Now, we don't like equations written in x equals form. We got to get y by itself. So next, we would work to get y by itself. And now we would have the inverse. Now, technically, to write the inverse, we would not write it now as y equals. We would say the inverse of f of x, or that f to the negative 1 of x equals 2x plus 5 over 2. So this is just some notation stuff. The actual process, though, like you can see, replace f of x with y, switch the x and the y, solve to get x by it, solve to get the new y after it switched places, solve to get it by itself, and then write it using that function notation. And even if they didn't give you a line, if they gave you a different type of equation, we'd go through the exact same process. Rewrite it as y equals, switch the x and the y, solve to get y by itself. The last one I want to show you that can be a little bit tricky. And again, this one right here is probably a little more than we'd see on a quiz, but it's worth noting just for a minute. We have f of x equals x squared. Well, we know that x squared is a quadratic. That's our parent function. But they give us this limit. They say where x is greater than or equal to 0. Well, if x is greater than or equal to 0, that would be from here this way. That's all those x values. So it's giving us that restriction saying we do not want the negative x's. We're only looking at this. Now, we would go and take our inverse. So we'd write it as y equals, switch our x and our y, and now we would square root both sides. Now, you guys know, I'm sure all of you are thinking right now, when we square root both sides, we can't forget our plus or minus. Well, because of this restriction that they put on, x is greater than 0, we are not worried about the negative of this graph. We only want the positive. So we don't need to worry about our plus or minus here. Because they gave this restriction, we only want the positive part of the square root. Then we would write it in the form that they like, -1. Well, we know that the square root of x is our squirrel's tail. So those two things right there would be inverses. There's your 2-second lesson on 11.2. Go ahead and knock out the big ideas next.